Thank you so much for being here. If we need more chairs, we have some in the back. We seem to have fewer chairs than people, but we'll get to it. So my name is Bobby Mitra. Before that, welcome to this special event where we celebrate the graduating NEET seniors. NEET is a small community, students, big community. The NEET team is a small community. And we are just so proud to see students here. More than that, I'm a parent too. More than that, I'm really happy to see parents and near and dear ones because we all look forward to this date, right? So thank you for being here. So doesn't look very much like me. This was when I had less gray hair than before. This is what NEET has done to me in a year and a half, just, that's me. Professor Ed Crawley, Professor Pekka Hosoi started NEET about 100 years ago. I joined 3 months after they started. So we are sort of three founders of a startup, didn't make any money out of this startup, but tremendous satisfaction. So NEET is a cross-departmental undergraduate program that prepares students to solve real-world challenges and advance frontier technologies at the intersection of disciplines. By offering curricular programs that bring students together in multi-year, it's a 3-year program, cross-departmental. So for example, in autonomous machines, there'll be students from mechanical engineering, computer science, aeronautics, and astronautics, together for 3 years doing projects, having pizza, listening to faculty, doing projects with Aurora Flight Sciences, fostering shared professional interests. This is something that doesn't always happen in college, where let's say if you're interested in applying mechanical engineering to disease and therapy, how do you do that? How do you learn about what it means to be in that domain? Right? So shared professional interests are important. And of course, MIT hands-on mens et manus, so that's a given, but hands-on, collaboration, mentorship. Mentorship has been new. It wasn't part of any design or vision or strategy, but sort of over time, because the instructors are with the students for 3 years, sophomore, junior, and senior, it's become an automatic mentoring relationship. And the other thing, important thing with mentoring is that the instructor and the students talk the same language. So that's very important. Otherwise, how often can you tell your advisee to be on time or do all the stuff they're supposed to do? And of course, professional development. So NEET scholars earn a degree in their major. I'm a little nervous, so I forgot that I had notes. Not that I need notes. So they earn a degree in their major and a NEET certificate in one of 4 high-impact threads: autonomous machines, which deals with autonomy and robotics; climate and sustainability systems, which deals with dealing with climate change; digital cities, which is about sustainable urban development; and living machines, which is how do you apply technologies to dealing with disease and creating therapeutics. So as an example, if you're majoring in chemical engineering, I used to be a chemical engineer by training and PhD, and you really want to explore how do you apply that to the understanding of therapies and to dealing with future disease. You join, of course, course 10, chemical engineering, as a sophomore, your department. You join a NEET program called Living Machines at the same time, and you graduate in the usual 4 years with your course 10 or 10B or 10Eng. I'm sorry, those of you who don't understand the numbers, talk to your children, they'll figure it out for you. And with a NEET certificate in living machines. So NEET is the 4th, NEET has grown a lot since we started with about 45 students in 2018, I think, seems a long time ago. So the interesting thing is that NEET is the 4th largest undergraduate cohort. So of course, computer science has the largest number of undergraduate students, followed by mechanical engineering. So here's a quiz for those of you. Those of you who don't answer, don't respond. What's the 3rd largest undergraduate major at MIT? Computer science, Mechie. NEET is not a major, it's not a degree, not a major or a minor, but it's the 4th largest. And what do you think is the 3rd largest major at MIT? You have 5 seconds to respond. Sorry? Electrical? Well, at MIT, it's part of computer science, so we count the whole thing as electrical engineering, computer science, but yeah. Anybody else? It's mathematics. Oh, I'm sorry, your hand was up. Were you saying mathematics? Okay. It's mathematics. So, we all know MIT is a bit of a weird place, but you live and learn. There are the 201 plus or minus students in NEET are pursuing 33 majors from 17 departments across 5 schools. What is really interesting is that about 13% are not from the School of Engineering. And they've kind of infiltrated this School of Engineering-led program, and that's great. It's very academically diverse and demographically diverse. 59% are women, MIT is about 48%, and 36% are underrepresented groups, MIT is about 22%, academically, demographically diverse. Thank you to our sponsors, starting with the School of Engineering. I've forgotten how to press this pointer thing. Got it. The MIT School of Engineering chartered and sponsored this 8 years ago. General Motors and Aurora Flight Sciences, which is a division of Boeing, were founding co-sponsors, which was terrific. MIT is working on a collaboration with GE Vernova over the next 5 years, and I'm glad to say that NEET is a very small part of that, but is part of it. And the 3 key departments, Aeronautics and Astronautics, course 16, Biological Engineering, course 20, and Mechanical Engineering, course 2. Other than computer science, we get the largest number of students from these 3 departments. Okay, so it's my pleasure and privilege to welcome Professor Rohit Karnik to the stage. Professor Karnik is the faculty director of NEET. Abdul Latif Jamil, professor of water and food in the Department of Chemical Engineering, and the director of JWAS. Rohit.
Thank you, Bobby. It's been really a very interesting journey for me to be part of NEET. I'm relatively new to NEET, about 2 years. But I have really grown to appreciate NEET a lot over my involvement. So it's really my pleasure to welcome you all here to our 7th annual NEET Certificate Conferment Ceremony, or NC3. Of course, congratulations, all the graduating NEET scholars, and also parents, family members, friends, and also all our staff and instructors. So just a round of applause for everyone. And thank you to all our supporters as well. So you, the NEET scholars, are here because you chose to go beyond your comfort zone. You chose to go beyond your major and explore a topic that you're really passionate about. And you successfully completed the NEET certificate program and are earning the well-deserved certificate. So to put things in context, today's world, there is a lot of grand challenges. There's also many exciting frontier areas, but they are not limited to single disciplines. And so they require really working together across disciplines towards achieving a common goal. And if you think about robotics, climate, energy, biotech, AI, it's not the domain of a single discipline anymore. And this is exactly what NEET prepares the students for, to succeed in careers that demand working in cross-functional teams in order to address today's grand challenges and to advance frontier technologies. So NEET is about crossing boundaries, or crossing disciplinary boundaries, to be precise. And it is about developing professional empathy by understanding diverse perspectives and knowing what it is like to be in the shoes of somebody from a different discipline. And by doing that, you can amplify what is possible by working more effectively together as a team. NEET is also about hands-on learning. It's about community. And all the NEET scholars, you really came together from across the schools, departments, college, and worked together, collaborated on projects, you built prototypes. And in doing so, you really created this thriving learning community where everyone could explore, learn, and also have fun. And through this, you build deep, meaningful relationships. So I hope that you cherish and continue to cultivate these relationships that you have built being part of the NEET community. And today you're joining the 200 plus NEET alumni as you graduate and go out into the world. And it's a world where there is rapid change, there's incredible opportunities, and no shortage of challenges. And it kind of demands new kinds of skills, adaptability, so the ability to see an issue from different perspectives, the ability to take a systems approach so that you can understand the bigger picture and the ability to continuously learn new things and continuously reinvent yourself. And by successfully completing the NEET program, you have equipped yourselves better with the skills and mindset that is needed to succeed in this world. So as you go out into the world, I urge each one of you to always think about how you can use your education and the privilege of being an MIT alum to create a more beautiful world. And I hope that you experience the joy and the satisfaction that comes from expressing your creativity and your ingenuity in your professional lives. So congratulations again, and my best wishes for a very bright and successful future. And now it's my pleasure to welcome Professor Paula Hammond, Dean of the School of Engineering, to the stage. So as most of you or all of you might already know Professor Hammond, she's a truly accomplished individual. So she's an institute professor at MIT with exceptional distinction in leadership, accomplishment, and service. She's very well known for her research in self-assembled polymers and nanoparticles for drug delivery with a focus on ovarian cancer. And she is one of the handful of people in the world who have been elected to membership of all 3 national academies. And she has a long list of honors and awards, but I'll mention one. She's recipient of the National Medal of Technology and Innovation. So thank you for joining us today, and please welcome Professor Paula Hammond.
Thanks so much, Rohit. And good afternoon, everyone. It is a real pleasure to join you for the 7th NEET Certificate Conferment Ceremony. I have heard about NEET and have had students, undergraduate advisees in NEET for many years. Today, I'm excited to hear what all of these projects are about. To our graduating NEET seniors, congratulations. Today is a celebration of both your individual accomplishments and the community that you've built together over the course of your time at MIT. And to the families, the friends, and loved ones who are joining us today, thank you for supporting these remarkable students through their journey. I also want to thank the faculty, instructors, mentors, and staff who make NEET a distinctive and meaningful program. Your guidance and commitment have helped create an experience that has a profound impact on these students. So today is about much more than just receiving a certificate. It is a recognition of the curiosity, the creativity, your persistence, your collaborative spirit, all of these things that you demonstrated through your work in NEET and across MIT. One of the things I admire most about the NEET program is that it asks students to engage with engineering in a way that reflects the intersections of knowledge and engagement across disciplines that they will see working in their own fields. The challenges that define our time do not fit neatly within the boundaries of a single discipline, and the 4 NEET threads really exemplify that idea. So whether you're working in autonomous machines, climate and sustainable systems, digital cities, or living machines, these areas require people who are willing to collaborate across fields, navigate complexity, and think carefully about the broader human impact of their work. And that is exactly what NEET was designed to cultivate. Since its launch in 2017, which is not 100 years ago, Bobby, but you can imagine all of the work that has gone into those past years, NEET has represented a reimagining of engineering education at MIT, one that embraces hands-on learning and interdisciplinary collaboration and project-centered discovery. And all of you graduating this week chose to be part of that experiment by earning a NEET certificate. That choice tells me a great deal about who you are. You chose to go beyond the traditional curriculum. You could have just taken what was in the guidebook, looked it up, and just gotten your degree, but instead you chose to work across departments and disciplines. You chose to see projects through from concept to execution. That's saying a lot. I was an MIT undergrad. I know all of the different things that can distract you and take you away from that execution, and yet you managed to stay together and make something with meaning. Throughout your time in NEET, you learned how to test ideas, adapt when challenges emerged, and continue pushing forward when things did not go according to plan. And just as important as the actual work, NEET also introduced you to the experience of building community. And I can tell that just looking at this audience and watching you interact. You have learned alongside people with different backgrounds, experiences, and ways of thinking. Class of 2026, as you leave MIT and begin that next chapter of your lives, I hope you carry forward the spirit of NEET. Whatever your journey looks like after you cross the stage on Killian Court this Friday, and I'll see you there, whether you pursue a career in academia, industry, government, or the nonprofit sector, your ability to collaborate across disciplines, to make with meaning, to welcome different perspectives, and to build community will serve you very well. We are incredibly proud of all of you, what you have accomplished, and we cannot wait to see what you're going to do in the outside world. Congratulations again to the class of 2026 NEET certificate recipients. Thank you. And I'm going to hand these over to Bobby, Founding Executive Director.
Thank you, Paula. And thank you, Rohit, both of you for your inspiring charge to the seniors. The bar is not very high, but go for it, right? So it's now my privilege and pleasure to invite to the stage Dr. Greg Long, the second youngest employee at NEET after me. I'll tell you about him some other day. Founding lead instructor, autonomous machines, one of the two threads that was launched early on, along with living machines, and lecturer at NEET. Greg, over to you. Rohit, if I may ask you to join us.
Okay, can I ask all the autonomous machines graduates to come up? And while they're coming up, I just want to thank family and friends for gathering with us this afternoon to honor our graduates. This has been a privilege for all of us in the NEET family to honor our students, and we are very appreciative that you're here with us to celebrate. So what you're going to see is we have 6 different groups. They're going to give a short 3-minute presentation of the work that they've done this year. And before that, I want to send a shout out to Janelle Gannum. She works at Lincoln Laboratory. She's a computer scientist. My background is in mechanical engineering. I've learned as much as I can about computer programming, but as you guys can imagine, it's a lot. And Janelle has joined us as she co-instructed the class with me this year, so we definitely want to appreciate that. So she's going to help with the certificate handing out. So what we're going to do right now is just a little bit about the project. So the project spanned, as Bobby said, we have mechanical engineering students, we have computer science and electrical engineering students, and this year we don't have any Aeroastro graduates. So you're going to see a variety of projects. So I'm going to now let the students come up, give a presentation, and Tom, you're going to be up first, okay?
After presentation, I think.
Okay, so this is Tom's Robot Dog project. As you can see from the slides above. So this is the robot dog that I spent the semester building. So this is the senior capstone project. The first semester, I was working on it like one direction mechanically. I was using planetary gearboxes, and then after the first semester, I was like, okay, things are cooked. And then I made one planetary gearbox that first semester. And I was like, this second semester, I really have to log in. So from pretty much just one gearbox that was designed incorrectly, going from that, and this entire semester with the support of like so many people in the program, I was able to get this fully completed, and the software has a little bit more to be desired, but we got Claude Code for that now. So it does walk. I'm not going to demonstrate it right now because it takes like 3 minutes to get started, but this is a full assembly, and I started with one gearbox. I'm using cycloidal gearboxes, which is like oscillating cycloids, and then I built one leg with a linkage system, so there's like little metal linkages here. And then I went and built the full dog. Next slide. Video demo. So I don't know if this demo is running, but this is it running it last time in class. Please. And this is actually the first time I've ever tested it. It's a little shuffle. This is the first time I've actually ever like had to like scoot around because I've been having trouble with burning out motors. And I was like, if I'm gonna burn out a motor, I should do it in front of everyone in class. Thankfully, I didn't burn out a motor. I did burn out a motor this morning though, and I was able to swap it out. But yeah, I was talking about planetary cycloid. This entire first semester, I worked like so much on planetary gearboxes. And then instead, I did cycloidal, and then what I put in the slide. I'll be honest, this entire slide deck, I didn't really want to like. I was working on other stuff, and then my Dr. Long was like, "Can you get a slide deck for me?" So I was like, since there's so much compiled information in my Claude Code and ChatGPT logs, I just like asked it to fill out relevant information and like give me a backtrack of the entire timeline that I did. And I was able to pop out this presentation in 30 minutes. That's also kind of why I forgot what's on the slide.
Post-graduation, what do you do?
Oh, post-graduation, I'm working, I'm co-founding a startup in the manufacturing space, and we just raised a seed round, so I'll be doing that full time.
Okay. Hi, my name is Julia. This is Amina. We're both seniors in course 6-4, and our project is called Bipedal Robot Locomotion with Reinforcement Learning. Our project had 2 objectives, the first of which was to teach a bipedal robot to walk in simulation using reinforcement learning, and the second was to teach that robot to walk through a maze. So our project is fully in simulation. We use Majoko. We had a few different reasons for using this, for doing this project. The first was to gain experience with reinforcement learning, because neither of us really had much practical experience with it. We chose the humanoid problem. Because it was a classic RL problem, and so it has a lot of learning materials available. And the third reason was we've added a maze expansion, so it's just a little bit more visual interest onto the classical problem.
And so our first objective was actually getting the robot walking. And so we used the default Majoko health reward function, and that includes the health reward, forward reward, which are basically it rewards the function positively if the humanoid is alive and moving forward. And we also have a control cost and contact cost, which penalizes it if the actions are too large. So these videos, they should be videos, but they're tested on 300 million time steps. And so it's basically showing that the humanoid is able to walk without the maze. But in the next slide, we're adding the maze, for which in the end, we actually determined that adding more direction-focused conditions was better, and so we added a curved waypoint path to make it more feasible for the humanoid to actually follow the waypoints, as well as approach rewards, proximity penalties, velocity rewards that basically reward the agent for getting closer to the next waypoint. And so we split it up into 2 phases for the training. First phase was 10 million time steps for walking, and phase 2 was 5 million time steps for navigation. And so on the next slide, there should be a video.
Yeah, those are both videos. I'm not sure if there's a way to get them to play, but the basic gist is you get to see the robot, which is spawn over in the corner there, walk through the maze up to where it is and eventually cross the finish line. I'm not sure if we can get them to play.
Yeah,
No. But that's the basic gist. It follows the waypoints to the finish line using reinforcement learning. So we talked, and if we had more time, we would do the following. We would like to generalize solution to different mazes. We mostly tested on the maze you saw on the previous 2 slides, but it should pretty easily generalize to multiple mazes. In the same vein, we'd like to work towards autonomously placing those yellow waypoints that you saw using A-star or a similar pathfinding algorithm. Again, that should be very easily generalizable. And we also like to compare more the training time required of a full RL approach with no waypoints, just rewarding it, just full RL, versus the RL and classical algorithm approach, which include the waypoints that we showed you. In addition, we also would like to get the robot to walk a little bit more with a human gait. It does walk, but it walks a little bit unnaturally, which is pretty typical of this problem. But yeah, thank you.
So hello everyone. So my name is Christine and my partner is Shalissa. She's getting the drone right now. And our project is building a drone for automated crash detection, which uses computer vision, simulation, and also physical implementation. And so we decided to build a autonomous drone system to inspect building exteriors because this is like I guess like currently the way you're doing it is like really risky and you have to like scale buildings. And so by using an autonomous drone system, it can make it less risky and also leverage technology to do something that is like good for the world. So first part was that we collected, or like we found a data set online with cracks, and so this is like concrete cracks. And we trained like a model on it to kind of like, I guess, tell if there's a crack or if there's not a crack. And so we experimented with many techniques. So we used transfer learning ultimately because we found that we were able to get like a pretty good accuracy and like really low loss, like relatively quickly and with less compute than like, I guess, training from scratch.
All right, and then the next part was simulating our drone on Gazebo. And first, we wanted to plan a path using waypoints. So you see 4 boxes in this environment here. We planned a very simple square path. And then once we figured out how to set up paths, we loaded textures of the cracks that we used in our data set and put them on geometries inside the environment. And afterwards, we used our successful transfer learning model and put that into simulation, and we saw that it was able to correctly classify the cracks within the environment. And then once it worked on simulation, we thought it would be a good challenge to put it on a physical drone, so we set it up so that the drone would fly, and then we printed out pictures of cracks to put on our walls, and then put a camera feed, put our transfer learning model on there, and it was able to detect some cracks. And I'm gonna try to set it up here so that you can see it. All right. I'll turn the laptop this way so you can see. So in the green, you'll see if there's no crack or a crack, and then I'll put this camera here so that you can see. Here's a picture of a crack that Christina's holding up, and hopefully you'll see a red, very ominous sign of crack. And then go ahead and switch Christine to a no crack picture. Hopefully it's a nice, vivid green. All right.
Thank you.
Thank you. So if you're interested in trying out or checking out this code for yourself, if you have some kids who are interested in drones, feel free to check out the website. You could also feel free to email us. Okay, thank you.
All right, hello everyone. My name is Xavier. I was working with Alessandro on this project, similar to Tom's, to build a quadrupedal robot from scratch. So he's just working on setting it up. We're gonna see if we can do a quick demo. But in the meantime, I can go into a little bit of the development. So inspiration is kind of the robots that you're used to seeing, Spot, the Unitree, GoTo, etc. In terms of mechanical design, I focused from the get-go on using cycloidal gearboxes. You can go to the next slide. And so how a cycloidal gearbox works is you have two cycloids here that are attached to an eccentric camshaft, and that camshaft is driven by a motor. So as the motor spins, the cycloids roll along an inner circumference of some pins, and for every one rotation of the cycloid around that wall of pins, the cycloid itself rotates 1 tooth with respect to the motor. And so after 20 full rolling rotations, you get 1 complete rotation of the cycloid, and that results in a 20-to-1 reduction on the cycloids themselves, which increases the torque output from the motors by a factor of 20. That's really important because these motors are high-speed drone motors, and by themselves they wouldn't be able to support the weight of a quadruped robot. In terms of leg design, I stacked 3 of these actuators together to give 3 degrees of freedom for this leg, with the final degree of freedom positioned right here at the top of the leg, and then there's a belt connecting that actuator output to this E-joint, just so that we can distribute as much of the mass as possible close to the top of the robot, or the chassis, so that we're not moving around unnecessary weight. And then once I had the leg design, I mounted it onto 2 aluminum plates, which are connected via some 80/20 support, and then we have our quadruped. Go to the next slide. So Alessandro will be setting up the demo right now. I can kind of go over the general framework of how he designed control. So the most important thing was really getting the motors up and running with the correct voltage. That requires a good power supply. Once we got that in place, the biggest challenge was getting the motors calibrated, which we had some trouble with. It turned out that the magnet that we used in order to detect the absolute rotation of the motors was slipping a little bit. So once we glued that in place, it solved a lot of our problems. We end up using for the communication Raspberry Pi with CAN cables. That's just the communication protocol that we were able to use to communicate each of the motors. If you want to continue with kinematics, etc., or...
Sure. I don't know why nobody likes these microphones around here. 10 seconds? All right, Xavier, can you hold it up? We're going to try and see if we can get this robot to do something. This is not going to be impressive, but it might move. Can you put it in the neutral pose?
So we had a little bit of trouble with mechanics, just making sure that the cycloidal gearboxes weren't skipping under too much belt tension.
Yeah.
And then we were having some trouble with software as well, but at this point we are able to get joint by joint position control, and so theoretically all you need to do is command a certain predefined trajectory, and then you can get the robot to stand up, walk, similar to what Tom was able to accomplish.
So we're going to run it now. Ready? And there it moves.
You can see that they're a little
Yeah.
out of a rate here.
This is supposed to be a neutral, like, standing position from which it would walk, theoretically. But yeah, that's our quadruped. Thank you.
How do you power it off? We can just bring it back.
Yeah.
Oh, what the? Okay. Hi, I'm Kyle. My project is Uzi. Uzi is a minimal bipedal robot, so 2 legs, that can talk and ideally follow voice commands. This is inspired by the Murder Drone show. The vision behind this is that the vision behind this is that it's like, you have robotic humanoids like Figure AI, which can help you perform tasks. This is kind of like a mini attempt at this. I think this type of project is better explained with the video, so. Yeah. So this is all run on a Jetson or a Nano, so there's like an onboard GPU, which is kind of hard to see on there.
Hey Uzi, how are you doing?
Still breathing, barely.
Who's your favorite League of Legends champion?
Bite me.
I mean, it's not that bad. Wait, can you go forward real quick?
Fine, whatever.
So this is an example of
Okay,
follow
okay,
basic
that's good.
commands, right?
Could you stop?
Yeah.
Thanks. Okay, so there's this problem on my homework. It says like 2x plus 5 equals 25. What is x? Can you help me?
Seriously? You needed me to stop for that? 2x plus 5 equals 25? Subtract 5, you get 20. Divide by 2. X is 10. There, done. Bite me.
Thank you. What do you think about our conversation so far?
So it has some memory capabilities.
It's whatever. You asked me to move, I moved. You asked me to stop, I stopped. You made me do basic math. Thrilling stuff. Really living the dream here.
By the way.
Okay. Great. Do I go back to this, I guess? Cool. So, as you saw there, I am a CS major, so the mechie side was a bit harder for me. I started with like an Arduino controlled instructable for the bipedal. I used Fusion to extend it, and then this was the assembly and wiring. I actually probably should have brought it. I forgot to bring it, but one issue is that it was kind of top heavy, so because the power bank was on the top, it made it a bit harder for it to walk and that kind of thing. In terms of the software and kind of firmware pipeline, this is all done on a Jetson. We start with input from the microphone, do speech to text. This gets sent through an LLM, which is DeepSeek, and then it does text to speech. This part also can like display emotions, which is kind of what we saw through Uzi. Up to the speaker, the display does some lip syncing, and at the bottom, we use tool calls in order to get to say walk forward, stop, do that kind of thing. And inverse kinematics is used to make the robot walk. Great, thanks.
Thank you. Hi. So our project is doing kind of classical control, but using an RL approach just to get our little robot here to self-balance and drive around. We are all mechanical engineers, so this is much more of a computer science project, so not as crazy in scope. So our main problem is trying to, one, get the robot to balance. This is kind of the classic inverted pendulum problem. This is kind of the core of like 2004, which is a class we all took. And then getting the robot to navigate around a set of waypoints. Again, a lot of the same things our classmates were doing. Like I said, we've done these problems from kind of the classical approach, which is PID control and then just kind of set point navigation. Our goal for this project is to do it all using reinforcement learning as the entire control scheme. So take away all of the classical elements and do it all through kind of machine learning approach. The hardware, just a quick run through. We bought this kind of robot kit online. It's a Polulu Balboa. It runs on basically an Arduino type board. It has motors that have encoders and then IMU readings that we can read from it using a serial port. We were trying to use a Raspberry Pi to kind of do all the software on it natively so it could be fully wireless. Unfortunately, the, what is it called? The voltage readout that the website said it gave is not enough to power the robot, the power the Raspberry Pi. It needs like a 5 volt, 5 amp power circuit. This actually only gives out 5 volt, 3 amp. So no Raspberry Pi. So anytime you see the Raspberry Pi in the slides, just all that software is just on a computer and then uploaded to the robot, but same principles apply. So like I said, originally we wanted to do entirely RL, so it was balance and drive around using that. However, we ran into a couple challenges. The sim to real, we were able to get the balance in simulation, but translating it from simulation to the actual robot just gave us a lot of issues just because of not being able to correctly model the IMU noise, the gear backlash, kind of the friction forces, and just like the inherent balance of the robot. It just proved to be really difficult, and as much as we fine-tuned it, we couldn't get it to work.
So we ended up switching to a cascade architecture. Again, PID control is really good at solving the inverted pendulum problem. It's really good at balancing. It's really powerful and it's really stable even without great models. So we decided to use PID for balancing and just reinforcement learning to navigate. So similar to what people before us have done, we have waypoint navigation where the reinforcement learning determines the path and the velocity commands to get from waypoint A to waypoint B. So we're now going to demonstrate. It was working before, so I hope it works. This is not very crazy. It's going to drive in a square, but here we go. Oh. All right. Sorry. All right, we're going to try one more time. Yo. There we go. So, gonna turn right.
Oh, into
right.
the wall.
I turned it the wrong way, but it drives in a square. So all of that reinforcement learning, all that navigation is found using reinforcement learning. So all the velocity commands, the way it turns, it's all done using our model, and then I uploaded the commands to the robot. Just the brief challenges. Again, the sim to real gap is just something that we had a really hard time overcoming. In the actual RL balancing policy, being able to fine-tune the parameters and kind of finding the right combination of like structure versus letting it learn on its own. And then the conclusions, this is something that we learned from Janelle, is that RL is really good for some things and not great for others, and that there's a really strong argument to still be using kind of classical methods even in the age of AI and doing all that stuff, which obviously is what we ended up doing. So yeah, thank you guys.
Right, certificates. How do we put this out?
Okay. All right, so now we're going to have a presentation of the certificates for our graduates. Okay, you guys ready to get your certificates? Okay. All right, so Alessandro Resnio, yeah, Tapia.
Thank you.
Okay. Christine Chin. Kelsey Fontenot. Julia Fort. Kyle Fu. Tim Harmon. Amina loves Sanchotum. Tom Wynn. Jolessa Orn. Xavier Sanchez. And Alex Shanafield. And thanks again.
So everyone, don't go away. There's a group photograph, please.
Squeeze in here.
To all the people in the back. Thank you. And as they say now, for something completely different. It's now my privilege and pleasure to invite to the stage Dr. Nathan Mellenbrink, founding lead instructor of the Climate and Sustainability Systems thread and lecturer at NEET, and Dr. Nathan King, co-lead instructor, Climate and Sustainability Systems, and lecturer at NEET. We call them the United Nathans, or they call themselves the United Nathans. So without much ado, Nathan, I'll hand over to you.
And we could invite the graduating climate sustainability seniors to the stage, please.
Oh, after.
Okay, I just have a few words about our thread. So our overall objectives are to build climate literacy. So we have students from all different concentrations in our thread, and one thing that we've learned is that climate means different things in different departments. Again, as Rohit mentioned, the really organizing principle of NEET is that we bring together students from different departments, different concentrations into cross-disciplinary projects. And so being able to have a format where students are able to build climate literacy with each other amongst peer-to-peer relationships, discussing climate topics which may be nebulous or even controversial, making a difference sort of at home and abroad, and we'll show some examples of both, introducing students to climate careers, and providing advising on climate career pathways and course roads through MIT. And we do that through a few different classes that we put on as part of our thread, a class called Decarbonizing Ulaanbaatar, which is our ongoing 5-year-long collaboration with the National University of Mongolia in decarbonizing the capital city of Ulaanbaatar. Our Intro to Design Thinking and Rapid Prototyping class, where we design and prototype a solar-powered charging station here on campus. Our Anthro-Engineering class, which is housed in the Anthropology Department and co-taught by Professor Mike Short, who's our faculty lead of our thread, and Professor Manduhai Bayandelger, who's Mongolian herself, and then our CSS seminar, which is offered every semester and provides that format for students to engage and build climate literacy. So one thing that we did a little bit differently, and Flora, if I could invite you to come up and introduce yourself. Speak about this.
My name is Florida Chichesa. I just finished mechanical engineering, and I also served as the CSS co-chair this year and also last year. Yeah, so I guess like our CSS seminars are an opportunity for us to connect as a thread, and like through discussions with guest speakers that we talk about like climate or renewable energy issues around like in the US or around the globe. And so, but this year, I guess this past semester has been a little different because we wanted to foster engagement across campus and off campus for our students to engage in different debates or conversation about like climate and renewable energy, not just on MSc campus, but across the Boston area. So here are a few examples of events that we attended and kind of had conversations about. Thank you.
And then, as I mentioned before, one of our flagship classes is the Intro to Design Thinking and Rapid Prototyping, where this year we designed and built on campus here in the Alumni Garden a solar-powered charging station. This is actually the students from this year's sophomore cohort disassembling it at the beginning of the fall semester before the weather got too harsh for it. But we hope that this will be an ongoing tradition here on campus, giving students an introduction to a little bit of design and human, user-centric design, as well as power electronics, mechanical design, and structures. And this was featured recently in MIT News. And I'll invite next Tyler, who was also a teaching assistant for that class.
Hello, everyone. I'm Tyler E., Course 2, or MECI for, I guess, non-MIT people. My postgrad plans are actually, I'm working on high-field magnets. So I'll be down in Florida working on magnet technology relevant in nuclear fusion systems, which is energy relevant, but also even in non-energy technologies like MRIs. But my experience with this thread has been pretty great, honestly. I mean, I had the opportunity to go to Mongolia during my this year's IAP. This trip was quite honestly fantastic, I think, in a lot of ways, and really eye-opening to a lot of the broader policy debates and also just general conversations around climate and energy systems. The heating required in Ulaanbaatar is incredible because you have a capital city with 3 million people and it's like negative 30 Celsius during the winter months, which is insane, right? But this was a really good experience. And during the semester, I worked on and off on the Mongolia capstone, which involves heating the 5-wall GARE. And with the GARE coming in from a Canadian company, sometime during the summer, we plan on instrumenting it with the wind sensors to get a gauge of the way convection currents flow throughout the GARE. Yeah, the capstone, and I really thank Nathan for a lot of things, and the thread's been fun.
Super. So yeah, Tyler worked this year on developing a custom housing and enclosure, and we looked at this circuit design and PCB design even for custom wind sensors to install in the GARE to better understand convection currents and thermal performance in that traditional Mongolian housing. This is a photograph from a previous trip to Ulaanbaatar where we instrumented the GARE with gas and humidity and temperature sensors that gave us a better picture of that. So we, in this year's cohort, and this is something that's really nice about this program, is that we're able to kind of build on each sort of subsequent, not like many classes, you just kind of repeat the same syllabus over and over again, but here we're actually, in prior years did one type of thermal sensor. This year we wanted to tackle the problem of understanding very kind of low current wind velocities inside of the residence and understand how that was affecting comfort and livability. And we matched those results to COMSOL simulations, which you see on the right. That was all work that Tyler worked on this semester. And then I just want to put in a quick plug for what's happening on September 8th, which you may know as Reg Day, but Reg spelled backwards is GARE, the traditional Mongolian dwelling. So we have already purchased and will have delivered a GARE that look quite like this one. We'll be hosting exhibits about our ongoing collaboration. We'll have a panel discussion with the faculty that I mentioned previously, visiting cultural envoys and Mongolian traditional musicians and dancers, and of course we'll be serving traditional Mongolian dumplings. So look for that on campus on September 8th. And with that, I would like to thank our graduating seniors. Sure. All right, and so we'll start, we'll do this in alphabetical order. First, we have Jad Abu Ali. Olivia Chen. Flores Cesar. Tyler E. And then Juliana Pertus. Thank you very much one more time for our graduating seniors.
Thank you. I discovered after the first cohort went to Ulaanbaatar 3 years ago that minus 40 centigrade is the same temperature as minus 40 Fahrenheit, both of which are difficult to visualize, but that it is what it is. So it's my privilege and pleasure to invite, Dr. Song Song, our Digital Cities lead instructor, for NEET and a lecturer in the Department of Urban Studies and Planning to the stage. And we are grateful to the School of Architecture and Planning for their leadership of this thread in collaboration with the School of Engineering. Another experiment within an experiment. So Song, what else?
Sure. Oh my God. Thank you. We are a small thread, so I will just give you a very brief introduction of what digital city is. So when you hear about digital cities, maybe you're thinking about, well, immediately think about the sensors on the street or cameras collecting data or maybe digital twins of the cities. They are definitely part of the picture. And what digital city programs mainly focus on is something broader, like what computing, data, and technology are going to shape cities and our urban life. And today we have a lot of discussions about how AI is going to change the way we interact with each other. So I think it's a time that is more important than ever to just to understand, well, how should we make this emerging data and technology more responsible, or how to use it in an ethical way, or how to make sure they are advancing the public interest in addition to pursuing commercial goals. So how does that work in practice? I forgot, I have 2 slides. How does that work in practice? In digital cities, we are offering a number of technology courses, including GIS, statistics, programming, machine learning, but they are offered in the urban studies and planning department and are led by urban study instructors, which makes them quite different than pure technical workshop, because we will spend a great deal of time talking about people, power, positionality. Because, for example, like, why do we use this particular type of model rather than the other one? And where the data comes from, who collected these data, whose perspectives are represented in this data, whose are missing, or what are not on this particular map, and how are your data analysis can possibly lead to misunderstanding or biased interpretation of this problem. So we critically look at every step of a data analysis process, because data and methods are almost never completely objective, and the models carry assumptions that worth further scrutiny. And we also recognize that not all of these knowledges come from classroom teaching alone, so we offer a lot of projects for the students to work with, or in some of the courses, we connect them with some community partners on community leaderships to help the students to directly work with the communities and understand their needs and aspirations. Well, with that, I think I wanted to turn to our certificate recipients. We have 3 recipients today. Not sure that all of them are here, but I have had the privilege to working with each of them. I have involved in teaching them and advising them, and I can say that every one of them is exceptional. They are exceptionally deserving this recognition, so I'm very delighted to offer this certificate to them. Let's see. So, Diego Temkin. I've heard from a couple of them that they are very busy this afternoon and probably won't be here today, but I will hold this certificate to them. And the second one, Lisa Li Liang. And the last one, Yi Hong Chen. That's it. So, okay, I will keep them.
Thank you, Song. We are very close to reception, so please don't go away. Before that, it's my privilege and pleasure to welcome to the stage Dr. Mehdi Salek, lead instructor for Living Machines and lecturer NEET. And Mehdi has a surprise, which I won't reveal, but he will as soon as he gets here. Mehdi.
Thank you, Bobby, for the introduction. Good afternoon, everyone, and congratulations again to all of our graduates as well as their families and friends. And this is the last presentation for today, but not the least. And we have the same format. I would like to ask all the living machines scholars join us in here on the stage, please. Here you go. So now we want to talk about the living machines. Our scholars actually prepared the presentation, and they want to share their experience at living machines with families and friends. And before starting the presentation, I would like to share a video from Professor Linda Griffith, who is the faculty lead of living machines. And unfortunately, who couldn't join. He's in a MPS World Summit conference in Washington right now. But she actually recorded a message just an hour ago and sent it to us. So I would like to play that short video first, and then we'll start with the presentation.
Hello, NEET Living Machines students, class of 2026. I'm so proud of you. You did amazing work this year, and you did amazing work your entire time at MIT, and have really so much potential in the future for solving real problems. How do we define problems, and how do we bring our technical abilities to work together in teams to solve these problems? I am so sorry I can't be there today, but I'm here at NIH and in the background, in Washington, DC, at a meeting of NIH-funded centers for drug development, centers that use organs on chips and microfluidics to represent the human condition to replace animals in testing. So it's been a very fantastic day of science here with 6 other centers in addition to our MIT Center, which focuses on women's health, sharing the plans for the next 5 years that will work together to improve how we study the human condition and represent it for women's health. And everybody's excited to hear that MIT has NEET Living Machines focused on this problem. So you were represented here at NIH today, even though you are not physically here. And again, congratulations. I'm so sorry I couldn't be there, but as the director of the program, I was required by NIH to be here today. Enjoy this week and enjoy your next steps as people who know how to solve problems so well.
Thank you. And at this point, we want to start the presentation by our great living machines students. So I would pass to Katie to start the presentation.
And we should all say postgrad plans as well?
Yep.
Okay. All right.
I mean, if you want, yeah.
Sure. Okay. Hi, everyone. My name is Katie Spivakovsky. I'm part of Living Machines on the synthetic biology track, which we'll explain more about later. Post-grad, I'm going to be earning my master's in biology at the University of Cambridge as a Churchill Scholar, and then I'll be getting a PhD in bioengineering at Caltech. But before all of that, I was once a high school senior deciding where to go for college, and in that research, I stumbled upon the NEET website and was immediately really drawn to the focus on interdisciplinary experiential learning. And so come freshman year at MIT, I immediately was excited to dive into NEET through the seminar class, NEET Ways of Thinking, which allows students to learn problem-solving techniques in problems across all 4 of the threads that you've heard from. Through this class, not only did I make some of my closest friends at MIT, but I also discovered that Living Machines was the perfect fit for me. And so Living Machines comprises actually 6 tracks, including synthetic biology, the one that I'm in, as well as tissue engineering and computational biology. And the curriculum for certificate completion really revolves around 3 main components, which include the coursework, research immersion, and academic and career growth. And so in line with that curriculum, I've had lots of opportunities to take classes both in and outside of my major, including NEET's introductory class on living machines, and this is a picture from my final presentation. I've also had chances to deepen my understanding of my own research and how to communicate it through the Living Machines research immersion class, which we'll go into more later. And I've had chances to attend talks and panels and networking events hosted by NEET and collaborating organizations. I'm going to go back a little.
And so my NEET experience really began freshman year, but the Living Machines experience began sophomore year with this class 20051, Introduction to Living Machines, which allows students to explore those 6 tracks within LM through mini projects. And I'll hand it over to Izzy now to go into a little bit more depth on this.
So, my name is Izzy. I'm a senior and I'm in chemistry and biology, and I was on the tissue engineering track. And so these mini projects, this is us in 20051, which is really the introduction to LM, where we go through different modules about sort of the frontiers of what bioengineering is. And this included learning how to use computer-aided design to 3D print. We did lots of lab tours, same picture of Katie. But we then used these 3D printed molds that we made we'll talk more about this in a second, to fill them with a polymer to make these sort of devices, which you cure with a plasma gun, which is something straight out of a sci-fi movie. And we even got to go to MIT Nano and get into the full clean room gear to etch Nobel Prize winner Mugi Buendi's face onto a silicone wafer. But the capstone of this class is the final project, where we were tasked with modeling some phenomenon using an organ on a chip, which is a microfluidic system microfluidic cell culture model that can be used to investigate integrated human physiology without having to use animal models as an approximation. So in the fall of 2023, we were tasked with modeling pain on a chip. And my group chose to model endometriosis pain. We built a system to help us model how the lining of the uterus is innervated by the peripheral nervous system in order to better understand how this sort of pain works, and to use a non-animal model to better approximate human physiology for things like drug testing. For the final project, we did a thorough lit review, wrote a faux statement of purpose, and designed our own model system, including experimental steps we would need to validate it. And in the process, we had a chance to talk with postdocs in Dr. Griffith's lab, including Dr. Holt, who would later become my UROP mentor. This project took advantage of basically every single thread of the NEET LM experience. And I was able to take this crude drawing in my notes app for this final project of, what are we modeling, how do we model it? And continue working on this project as a 2-year-long UROP. So these are some micro-wells that I manufactured that would hold a co-culture of a 3D suspension of human endometrial cells in addition to peripheral nerve cells, which is pretty cool. And then I had the chance to engage with the second part of the NEET curriculum, which is research immersion. I continued my UROP in Dr. Griffith's lab, like I said, and supplemented this by taking 20054, which supported my communication skills and helped me strengthen my understanding of the research process, which I had never been exposed to. We wrote research proposals, did all sorts of different types of presentations to bolster our communication skills, and made posters to share our research with the rest of the community. So I will pass it off to Clarence to talk about your experience with 20054.
Yeah, thank you. So, hi, my name is Clarence. I am a senior in biological engineering and chemistry. And bridging off what Izzy said, this research immersion component of the NEET LM curriculum was really a fantastic experience that allowed us to integrate our UROP into the program and explore our UROP through this lens of communication and interdisciplinary research. So my specific project was in Ed Boyden's lab in course 9 and 20, and it focuses on using fluorescent biosensors to do neuroimaging. So these fluorescent biosensors, these are engineered proteins that change their fluorescence based on a specific signal. For example, this cell over here, it's kind of blurry, and I don't know if you guys can see this, but it's like glowing green. And this cell is expressing a protein called GCAMP6F, which is a biosensor that
detects calcium. And you can basically use this biosensor to record the levels of calcium in the cell in real time and directly study whatever disease model that you want to do at the cellular level. So these are very powerful tools to study diseases at the cellular level. My project focuses on clustering together these biosensors, which is the method of multiplexing. By clustering together these biosensors into distinct domains in the cell, you can record from multiple different biosensors from a single cell at the same time. So for example, this cell is expressing these 3 different types of biosensors, and through the co-expression of these different biosensors that are clustered together in different parts of the cell, you can record these 3 different signals at the same time, which allows you to have a really comprehensive like window into the cell's like complex signaling pathways. Okay, so my year-out project that I explored through NEET, through the NEET research immersion, was composed of like 2 key questions. First is, how can we use these really powerful emerging AI protein modeling methods to streamline experimental testing? The second key question was, can we apply the approach here, the clustering of these biosensors, to biosensors that localize on the membrane rather than inside the cell? And I'll talk about each of these like piecewise. But the first method really focused on the ability to evaluate the peptide complexes using AlphaFold, because the clustering of these biosensors is mediated through these self-assembling peptides that are published in the hundreds in the literature. And that's a balloon, just warning you guys, or reassuring you guys. But okay, so there's hundreds of these peptides that are modeled using, or that are developed and published online. And the challenge is trying to figure out which ones to use in our experimental testing. So the pipeline that I developed in my lab was using AlphaFold to model these structures of these peptides, and then using molecular mechanics to kind of estimate which peptides had the strongest affinity to each other and the lowest affinity to different peptides. And then selecting the highly orthogonal peptides to use in our experimental testing. So kind of using AI protein modeling as like a prioritization method. Okay, the next question was, can we cluster the like membrane localizing biosensors? And this is important because there's many different signals that you can detect. For example, going back to these slides, you can see that these biosensors specifically detect calcium, cyclic AMP, and protein kinase A, which are signals inside the cell. There's also signals from outside the cell coming into the cell. For example, molecules that bind onto the cell membrane that you might want to study. So for those types of signals, you need biosensors that cluster on the membrane. So trying to figure out how to cluster biosensors on this like 2-dimensional surface rather than a 3-dimensional surface, which 3-dimensional interior of the cell, was a key challenge that I decided to tackle. So I basically used these AI protein modeling methods that I talked about earlier to search for peptides that could cluster in sheets in 2-dimensional arrays for the clustering of biosensors that localize on the membrane. And all in all, this was a really good example of like the cycle of engineering applied to this specific question, which was, how can we go from the design of our biosensor fused to the self-assembling peptides to building the DNA constructs encoding these proteins and testing them in cells, seeing if that worked, and then applying, like doing the iteration back, taking the lessons learned from testing back to the design phase, and integrating different principles from computation, from biology, from chemistry to make this tool work. So yeah, that is the end of my section, and then transitioning to Ayantu.
Hi everyone, I'm Ayantu, and I will kind of transition with Danny from the academic component of NEET with the intro class and the research immersion to the last component, which is the academic and professional growth. So one major component of this is our mentorship program, which is student organized and basically allows for us students to be paired with alumni industry mentors to get advice on research, careers, basically anything that you want advice on, as well as just general networking opportunities with industry professionals. We've had networking nights and other opportunities kind of one-off during the semester to connect with people and kind of grow our careers in that sense. So some of the companies that have been represented in our events are listed here, so a lot of very cool biotech companies, especially in the location we are here in the Boston-Cambridge area. It's been really nice to have that opportunity to connect with people. Do you want to continue social part?
Yeah, so I definitely think it's this professional development and social development that sort of sets NEET apart from a lot of other groups on campus. Going to seminars and learning about what sort of work is being done and how the stuff we learn about in the classroom actually contributes to real problems is really amazing. And then once we know how these problems are being addressed, using professional networking to find out who is working on them, whether that's in academia or in industry, and learn how to interview with them, talk to them, and get a job is really important. And I can't stress enough how important the social aspect is as well. We have a lot of social events where we get to talk to both previous NEET alums and people who are currently growing up in the track underneath us, and it's really great to talk to all of them. I was super happy at our most recent poster presentation. There was a few alumni from the 2025 class who showed up, and I think all of us are looking forward to similarly continuing to contribute to the NEET family after we graduate.
Thank you very much. Talking about the community, we are very much actually proud of our community, and I would like to emphasize that after graduation, you are still part of this community. Please stay connected. We have plans for our alumni, and this is something, as I said, we are very proud of. So, last sentence I say, it was a great pleasure, actually, very rewarding experience to work with such talented and dedicated students, and congratulations again, and all the best with your next step. And I think I can start announcing the awards, certificates. So they are just random, we didn't sort them, so. No alphabetic, nothing. So, yeah, I would start with Sean Luke, please. Congratulations. Pari Latawa. Matthias Vergara. KTS Paiwakowski. Isabella Luca. I think Julie couldn't make it today, but yeah, her certificate is here. Actually, she was one of our leadership team helping organize some of this event, and she scores 10. Geoffrey Envere. Danny Antonelli. Clarence John. Ayantu Tamane. Grace Hutter. So now I think we're going for a picture. Oh, you closed up. Oh, sorry.
Thank you. Gretchen Ertel, who's taking photographs, has photographed NEET students and projects. She knows NEET better than any one of us. Thank you very much. Before I move on to the next part of the program, I'm going to say something about Katie Spivakowski. And I'm sorry for singling you out. But when she was in first year, I heard from someone that she came to MIT, that NEET was one of the deciding factors in her choosing MIT. And I remember I tracked her down. We sat down at Pete's. I discovered she doesn't have tea or coffee. But anyway, I had my coffee. And I asked her, I said, is this true? And she said, yes. And I said, I don't believe you. And she said, but I said, yeah, how did you find out about NEET as a high school student? So anyway, you heard from her how she found out. So let me move on to 3 core NEET team members that it's my privilege and pleasure to introduce. And as I mentioned your name, would you please stand up so others know who you are? Dr. Rhea Lovey is the curriculum designer at NEET and the digital education lecturer and curriculum designer in Aero and Astro. He also teaches the first year discovery class, SP 248, the NEET experience, which some of you have gone through before you came to NEET. Sarah Makalo. Sarah, where are you? Sarah is the NEET communications officer and the project lead for the NC3 project ceremony. So another round of applause for her. And Paulina. Paulina's continuing to work. There she is. She's the NEET. Paulina is the NEET administrative and financial assistant and is responsible for all the arrangements and logistics for making this event happen. So another big round of applause to Paulina. I now request Sarah, who's already at the stage, to thank our students.
Yes, so we're closing out with a quick thank you to our students who went out of their way to help us out with events and community building, being representatives for the program and talking about their work and encouraging others to take part in this learning experience. Katie, Xavier, Florida, Tyler, thank you so much for all of your help, whether it was, the solar charging station, taking photos at events, speaking at tables, being on the panel for first-year students. We really appreciate you so much, especially with, our small team trying to make all of this happen, and you guys really helped us out in a big way, and we are so grateful. Thank you so much. These are just a couple of photos from events that we've had. We'll have our photo booth back there at the reception. And I just want to say one final congratulations to the class of 2026. Thank you guys so much for coming.